Okay, this is example 4 from section 3.4, and what we have is we have a position function given here. It says a dynamite blast propels a heavy rock straight up with a launch velocity of 160 feet per second. Okay, it reaches a height of s, and that's given by the position function 160t minus 16t squared after t seconds. How high did the rock go? So again, this is your position function, and this gives you the where, and this is when. So actually the t is the when. All right, that's how many seconds, that's time. And this actual s of t, this tells you where it is. It's going to be going up and down because it's blasted up, and it's going to go up for a while. It's going to slow down, and then gravity's going to bring it back down. So when the rock stops going up, it starts going down. So when the velocity equals 0, the rock is at its maximum height. So it goes up, stops, and comes back down. So it stops when the velocity is 0, so that's when it's at its maximum height. So all we have to do is, first of all, find the velocity and find out when the velocity is 0. So we can find the velocity by taking the derivative of the position function or the distance function. And the derivative of 160t is just 160 minus 32t. Again, this is the when. And if I solve this to find out when the velocity is 0, if I subtract 160 from both sides, divide by negative 132, I get 5 seconds. So 5 seconds is when the velocity is equal to 0. Now I can put this back in the where function to find out where it's equal to 0, and then I'll find out its maximum height. So I put 5 in the original velocity function. This was the position function, pardon me. So this is my position function, s as a function of time. Now I'm going to put 5 in here. That's going to be my time. That's the when. And I want to find out where it's going to be. That will be the maximum height, because that's when the velocity is 0. Okay. So I have 160 times 5. That's 160t minus 16t squared minus 16 squared. That ends up being 800 minus 400, which is 400. So 400 feet is where I am when t is 5 seconds, and when t is 5 seconds, that's when the velocity is 0, so that means I'm at the top of my little trip there. Okay, so the maximum height was 400 feet. Letter B, what velocity and speed did the rock, what was the velocity and speed of the rock when it was 256 feet above the ground on the way up and on the way down? So basically, I know the position. My position would be 256 feet. I just want to know when. That's the where. So I can put this in the position function and just solve it. Just see here, okay. So we're going to set this equal to 256. So if I put everything on the right, I would have a positive 16t squared, a negative 160t, and a positive 256, and I just reversed them using the symmetrical property of equality. And then I could factor out a 16, and I had t squared minus 10t plus 16, and this factor is easily enough to be t minus 2 and t minus 8. Sides are the same, they're both negative. Okay, multiply to give 16, and it'd be 10, 2, and 8. So I have 2 seconds and 8 seconds. They might say, the where is 256. Why do I have 2 different times? Well, basically it's going to go up. It's going to go up to its maximum, which is 400, then it's going to come back down. I just drew it as with a little curve here so you can see it, but actually it might go straight up and straight down. But it would go up, it would cross 256 feet after 2 seconds, go all the way up to 400 feet at 5 seconds, and then come back down. It would hit 256 feet at 8 seconds, and then plop on the ground. So that's when it is. Okay, we have to continue this now. That's the time when it's at those heights, and they wanted to know, the question was, what was the velocity when it's at height? So now we know the when. So we're going to find the velocity, because the velocity is basically this v of t, which was, remember, this was 160 minus 32t, but the when was t, and we know what the when is now, 2 seconds or 8 seconds. We want to find the velocity at either of those times. So I can put 2 or 8 into this velocity. 160 minus 32 times 2, which is 160 minus 64, which is 96 feet positive. That means I'm going up. And then here when I put 8 in, I get 160 minus 160 minus 32 times 8, which is 160 minus 256, which is negative 96 feet per second. And that means my velocity is negative, so I'm going down. Well, that makes sense. I'm going up, and I'm going down. So the velocity going up was 96 feet per second at 2 seconds. And coming down, it was negative 96 feet per second at 8 seconds. Now, since the speed was the absolute value of the velocity, the absolute value of 96 or negative 96 is 96 feet per second. So up and down, the speed was 96 feet per second. Okay, letter C. What was the acceleration of the rock at any time during the flight after the blast? Well, the acceleration of the rock is just the derivative. So acceleration is just the derivative of the velocity. The velocity was 160 minus 32t. So if I take the derivative of that, that would be just negative 32 feet per second squared. And you can note, because it's negative, as you're going up, you're slowing down, and coming down, you're speeding up. Okay, and then the last part, letter D. When does a rock hit the ground? Well, this is the position function, so it's on the ground when the position is 0. So I just set that equal to 0 and find out what value of time makes that 0. That'll tell me the where is 0, what's the when time. Okay, so let's move this up here. There we go. So what's happening is if I set this equal to 0, it's easy enough. I just factor out a 16t, and I get 16t, 10 minus t equals 0. If I factor out, if I set the 16t equal to 0, I get t equals 0. If I set 10 minus t equals 0, I get t equals 10. Well, it's going to be on the ground. The position will be 0 twice, at 0 seconds and at 10 seconds. Well, that makes sense. It's going to start its trip. So if we look at this little sketch I did up here, or over here, it's going to start here at 0 seconds. It's going to go all the way up. It's going to be here, I think we came up with this at 2 seconds. That's 5 seconds. Then coming back down 8 seconds, hits the ground at 10 seconds. So most of the situations where you start on the ground and you go up and back down, you're going to get two values for 0 for the position function, your beginning and your end. So I get that by just setting the position equal to 0. And it works out. Okay, so I hope that kind of helps you kind of see how we can kind of go back and forth between the position function and the velocity function to kind of get the conclusions we need to draw from any particular problem. Hope that makes sense.